Hi guys, this is Sebastian from Madrigal, and welcome to another hyper development video. Last time we got basic pathfinding working in the game, so now enemies can use the nav mesh to figure out a path from them to you, which also takes obstacles like this into account. You can see them drawing the path that they're going to take when they want to find how to get to you. And we can use this information now to set up basic movement. So these first enemy types that I'm putting into the game now, they should essentially just walk towards you, and when they touch you, you die, you lose the game essentially. And so this path information should be everything we need to actually make them move to you. So if we take this guy here, for example, he has a path where he has 1 point here, 1 point here, and the final one is here right next to the player. So essentially all he needs to do is start with the path and move towards the second point essentially. And if he reaches that and the path is still valid, then he will switch to the next, etc., which in this case will be the last point. Now obviously the player won't stand still for very long. He will move around and try to evade all the enemies coming at him. So the enemies will need to get new paths, refresh their path almost all the time. And currently they do it once per second. I think that's probably something that we can live with for now, and we can tweak it later on if needed. But the logic remains the same. Every time they get a new path, they start moving towards the second point on that path, and so on. Here's an interesting thing. This guy stands here, but his path actually begins from here. Now, why would that be? That becomes clear if we look at the nav mesh. So he actually stands, from a nav mesh perspective, he stands in a forbidden place, so to speak. And there are two things here that are responsible for this. Like, first of all, the logic that spawns enemies is still using our hard-coded offset, where like the player is here, then the enemy will appear roughly around here. So I was simply standing in this place when this guy got spawned, which is not something that we want to have in the future. I'll need to write some logic to figure out good spawning positions. And the second problem is that like this area here that's considered blocked is a little too big. Like this is something that needs to be tweaked in the level editor currently, and in the future when we generate the levels procedurally, the system just needs to know that to not make them this big. So this is tweaked with like the agent radius. So from here to here, for example, is considered the radius, and these guys are clearly smaller than that. So he can clearly stand here, even though the system says he can't. But you can see here that the path that is generated, it goes like flush against this edge here. So you'll want to leave a little room, or people will sort of bounce into walls like this when they try to move along the path. Okay, so we should have everything we need to get the movement done except for one thing, and that one thing is the actual movement of the character capsule. If we look at our object types here, we have player character and enemy character. They are almost the same, except the material is different, and well, the player has the player component, the enemy has the enemy component, but otherwise they are the same. And this movement component in particular, which is responsible for moving player characters around, we need to come up with something different for the enemies. So if we let's shut that down and go. All right, I'm already here. So it's a pretty simple component. This is on the C++ side. It's an avatar tracking component, which is sort of like the first red flag. Like, enemies aren't going to be avatars, so there's no point in having an avatar tracking component on an enemy. And the most interesting thing here is perhaps this character controller, which is the one that forwards the movement vector to the actual physics system. So that's what we want to affect for the enemies as well. And if we look at the actual logic, there's quite a lot of stuff here that's not used. Like, this is originally from a previous project that didn't really go anywhere, but there's some leftover code here. This is essentially the most important thing in the whole component currently. And so pre-tick and tick are the fixed update methods. Pre-tick is fired before the physics simulation and tick is fired after the physics simulation. So since we are affecting physics here, we want to do it in pre-tick so that the simulation immediately picks up on that and affects the things in the scene. So for the player, this makes perfect sense, because if we're on the client and we have an input buffer, and an input buffer is only available on the client if it's the local avatar, then we read the horizontal and vertical movement values out of that. And this works for both keyboard and gamepad and whatever else you have mapped as an input device. And then we combine that vector with the camera to world matrix, so that right means right regardless of how the camera is rotated and so on. And then we set that value to this M movement vector member. And if we look at what it is, it's a propagated value. Propagated values are essentially just wrappers around ordinary values. So this is just a 2D vector, but it's propagated across the network. And so what we're doing here is essentially the client is writing to this movement vector, which makes that value available to both the client and the server. And that's a little iffy. Typically propagated values are written on the server and read on the client, and that's kind of like the good way, because then the server is authoritative over that value and the clients simply obey, which is good for security and hack proofing and just like general cleanliness and to avoid subtle bugs in multiplayer games. That's how it's supposed to be. So the fact that the client is writing to this at all is just because when we become the avatar on the server, we actually set the game object component ownership to the client in question. It's a bit messy and we don't really want to do that. So let's try to avoid that. After that, though, when we have this value available, if it's 0 or close to 0, then just set the movement vector to 0. This is just so that we don't drift around if we're playing with, say, a gamepad and there's just a tiny amount of movement, then you don't want to run into a situation where like the player character moves like this whenever there's a little bit of drift. So there's a check here that just sets it to absolute 0, and then otherwise, this is the important part, we get the value out of the movement vector, which works on both the client and the server now because it's a propagated value, and apparently we scale it with 5 because some time ago that was a good value this is years old code. So yeah, we'll want to do something similar for enemies. And while we're at it, let's do that in Zig as well, because this is C++ code, and we're trying to write as much as possible in Zig. So everything except this this character controller is already available to us. And if we look at what it is, it's a very simple class currently. Essentially everything we need is this. That's the only thing we need to expose to Zig currently, but yeah, while we're at it, I guess we can expose these two as well. And once we have that, then we should be able to write a very nice server-driven enemy movement component. So let's do just that. Okay. First thing we'll do is look at that exposing thing. So we go to our bind.lot file and find the other physics classes. So here we have the physics scene, material, shape, and actor. And we'll simply add a character controller here as well. And actually we can maybe add the file for it. So let's just call it character controller.zig, and we put it in the physics folder, and we take that as a template and then just start copying over the things. So this will be a class that is kind of shallow. I don't have a good term for this, but there are a number of things in this Zig API that is essentially just like a shell around a C++ class. Like obviously we can't create a character controller like this in Zig and just assign that to the C++ class. The physics engine won't know what to do with that. So what we actually want to do is when we create one of these guys, it creates like the equivalent C++ class and uses that, and this struct here simply calls that class's methods, and then it will fit into the whole game engine system. And physics material, as you can see, is very much the same thing. Here's something commented out, but you can ignore that. Essentially, the only thing it has is this C++ pointer, and all the methods simply go through that when they want to do something. Well, this guy doesn't really have anything interesting to do, but if we have there's not really anything interesting here. But here we have, for example, physics actor. It has an actor type, but again that's the important one, the CPP pointer. If we set the world transform of this physics actor, it just calls down to the C++ side and passes the CPP pointer along to it. So it doesn't really store anything itself. It gets all its data from the C++ class, except apparently that one for some reason. Okay. And so let's have a look. Let's have one more look at this guy. So what we'll want to have is essentially these two. All right. Yeah. Zig doesn't have C block comments for some reason. I kind of wish it had, but it doesn't. So these are the methods that we want to expose. So let's just quickly create them here. We have we have public function set movement vector, and we'll want the vec2 and vec3 here because we're gonna use them right away. So movement vector would be a vec2, and I guess we need to do this now because otherwise it's gonna complain. Yeah, I don't know why Sublime Text sometimes does that on this machine. It doesn't do it on all other machines. And then get movement vector as well. Oh, and I can already see something that I forgot. Let's just do that for now. Obviously, we need the self argument here as well. So like that. And then let's do the come on. Let's do the linear velocity one as well. And yeah, I think that's probably all we need for now. Just to make sure that we can actually build this while we're fleshing out the rest of the stuff. Yeah, that should be everything we need for the character controller for now, and possibly for the whole game. I'm not sure. Okay. Then we need some way to actually get a hold of this guy. How would we do that? So if we look at the C++ component again, it gets its character control transform from the character transform component, and it has a get character controller method. Now we can't access this from Zig. Transform components aren't really a thing in Zig at all. Instead, we have this this transform API here, which can be used for similar things. And I was thinking maybe we can actually just add a method to this guy, which goes to the C++ side and figures out how to get that pointer from there, because it's easier to do all the messy stuff on the C++ side, and objects already have this transform API anyway. So I think we'll do that. So that would be let's see. So we have physics here. We need to actually need to do like character controller like this, and then we kind of forward declare, or I don't know what the term for this, but yeah, it's character controller dot character controller. I think that was the way we named it. Yes. Okay. So now we have this physics character controller here. We probably actually don't need to do that. We can just do get character controller. And obviously this is not something that you're supposed to call unless you have a character controller, and we'll probably just put an assert there or something like that. But that should be fine. So yeah, do something like this. I know I'm copy-pasting code around quite a lot in Zig because I don't really remember the syntax for things yet. I have done so little Zig. But yeah, we only have the CPP pointer to set, so essentially this is just when we call character controller, we return a new one and set the CPP to 0, and for now we need to do that dance again because you're not using self yet. And let's make sure this builds before moving on. And it does. Okay. Right. So now that we have this, we could in theory already write the gameplay code because we can get the character controller and we can obviously call set movement vector on that. But I think we'll tackle the binding stuff first. It's gonna be pretty quick, I think. And then when we have that done, we can just spend the rest of the video in Zig land and write the gameplay for the code for the movement stuff. So let's have a look. What do we have in bind a lot? Like we created the character controller already. That's fine. We can probably figure out the import path to that guy. So it basis physics and character controller, and physics objects in C++ in this game engine are reference counted. So they all derive from this physics counted object, which has an add reference and remove reference method. And because of that, when you look at these other physics things, they all have like add ref and release. I've been planning to rename the remove reference to release for a while, so I already did it here in the Zig API. And so I think we should have that, even if we're not really gonna create any character controllers in Zig. Currently, we're just gonna get things, get the controllers that the transform component has created for us. But it still makes sense, and it's good practice to add a reference when you get a hold of it, and then release it later. So let's have that. And for each and every one of these, we need to start with the CPP pointer. These create things have actually the physics engine CPP pointer rather than the object CPP pointer, because they are actually returning the CPP pointer to the actual physics actor or physics shape. Again, we're not going to create any character controllers from Zig, just get ones that C++ creates for us, so we don't need that. We do, however, need the methods that we created here. So set movement, and get linear velocity. Yeah, essentially these guys here. Let's copy them from C++ and fix them up so that they work with bind a lot. Like that. And this is supposed to be a const interrupt vec2. Getters don't return values in my API because I've had some bad experiences with that on some platforms, namely macOS. Returning structs hasn't really worked, so instead I return values through like writable parameters, non-const pointers, in other words. And then we have have the linear velocity there as well. Cool. Alright, that should be everything we need for the character controller. And that's supposed to be vec3 actually, like so. And then we run our, actually we might need that, but we don't need the video folder, so we can use this instead. And we go to basis, and we go to hyper, and we go to Zig source. No, we don't actually go to Zig, so we go to the engine side. We go here and to C API, and then we run the batch file, which runs the bind-a-lot.exe. And this should have now generated a bunch of stuff for us once again. So we got a new bind character controller function. We got the function pointers that we can already take and put in here, like this. And we got the class bindings, so the C++ side stuff. Addref and release can essentially just be copy pasted here, except we want these ones and so on. So let's just fix this up before continuing on. So we'll want a movement vector which is of interrupt type, so we should be able to do movement vector to interrupt, and then we can call, let's quickly look at that. Yeah, okay, I already forgot some things. Of course we need these ones, like I mentioned and then immediately forgot. So just run the batch file and we should be good to go. And since we used pointers, we need to take the address of them. Here we do something a little different. I think I did, what was it? C-node probably has something similar. Yes, we create an interrupt first, and that's supposed to be interrupt vec2, and then we call the function pointer self cpp pointer, and with the address of interrupt, and then we can return vec2 from interrupt like that. Yeah, it's a little annoying that you can't reliably return structs from C currently, but I think it's a bug and it's going to be fixed, or it is definitely a bug because it causes crashes. It will be fixed sooner or later, and this is going to be essentially just the same thing, except we have a vec3 and that. Okay, and now we should be able to build. There's one more thing we need to do on the SIG side for the binding though, and that of course is this function pointer, which is supposed to go after physics actor. If we stick to the order, so it goes here. Oh no, not that. Sorry, it's this one. Like so. And hopefully if you've been following the videos, you can sort of start to see how the binding works. So again, this gets called by the engine, and we simply store the function pointers that are coming in, and function pointers, these guys, are simply these guys. So pretty simple stuff. All right, so now the binding code on the Zig side is set up. We still need to do the C++ side. Actually, that's not completely true. There's one more thing we need to do here, and it's on the context. So we need to somehow get the character controller. And how do we actually do that? So the transform API, it uses the context CPP pointer. Yeah. Okay. Yeah, and that's fine. We can use this method that we created here, or function, shall I say, to get the character controller by going through the context. So we do void, or do we? No, we don't do void. We actually do uint pointer t, which is just the C++ pointer to the character controller represented as an unsigned integer. And we do get character controller, and then we do interrupt typed pointer, which is a special case used currently only by the context. Yes, that will get us the pointer to the character controller on the C++ side. This is a little boring as content go. I'm sure it shouldn't be much further now, when we'll have our shining new character controller usable in the game. So just copy that there. I added the one parameter to that method, and the same thing goes to here, like this. And now we can actually use that to get the CPP pointer. So essentially we do this. We do self context CPP pointer, and that should be it. Yes. So when we call get character controller of the transform API, we give it the context CPP pointer. We get back a CPP pointer, which we immediately feed into this character controller class that we created here, and then this will be valid. We can call these guys on it, and it will work. Excellent. Okay, so now this is the now the Zig binding side should be done. And it's built. That's always nice. And we can move on to the C++ side, and let's try to do this quickly, because even I am getting bored of this binding stuff. Interrupt. Want the context side for this one. Context. Get the bind a lot file. That one. So it will actually not be a void, but a uint pointer t. frame state. Yeah, what do we do to get that? What do we do to get that? Transform API. Let's see what is the transform component. I'll do that last. It's the most complicated thing. Anyway, so let's do it last, and let's add this here. That should be it for the context side. And then we will want a static void bind character controller. Again, we go to bind a lot. Take the character controller methods out of there. Yeah, we'll probably need to include it. Character controller. And now we can simply reinterpret cast that into a character controller like this. And that's essentially how we access the whole thing. Call that CCT. And then set movement vector, and this will be from interrupt movement vector, and is that how it works? Yeah, seems to be how it works. Okay. So movement vector equals to interrupt and CCT get movement vector, and there we go. And now then we just need to we added this new guy here, and we even added that same guy here. We don't have the function here yet, so let's add that as well. Bind character controller function. Bind character controller. And back to here and bind it. Okay, so set movement vector. Come on. And then get movement vector. Get linear velocity. Why won't you give me the things I want? Release. I seem to have made a typo. Here. So let's just fix that up. All right, and finally, library, Zig library manager. We go here and we hook up bind character controller, and we do the same thing here. Yeah, so adding new types is kind of quite a bit of work currently. Adding new methods to a type, or exposing new methods to a type isn't that much work, but adding a completely new type is annoyingly quite a bit of work still. I need to make this more streamlined. Then we have this guy, which, yeah, there's a little bit of magic involved here, which I'm not so fond of. Yeah, these guys derive from game object components, so we can just call get transform component on them. So let's have transform component and call that T. And that's T, and that's get transform component, isn't it? I think it is. Yeah, component has no transform component, really? Why? Oh, right. No, it doesn't have actually. We need to go through the parent. So get parent transform component. Right. Yeah. Maybe we can actually do it like this. This is how I've done it in other places. So you get the parent, and then out of that you can get the actual thing you want. I'm gonna pause this and speed it up a little bit. Be right back. All right, I'm back. Yeah, it took me a little while to figure out how to actually get to the correct type. And there's a fair bit of nasty casting here required to get this to work, but oh well. Luckily this is something that we can just call once and then store the character controller pointer, so that should be fine. Actually, there's one more thing I need to do here. Get character controller is actually what we want, yeah. So luckily this is hidden away from us in the dark woods of the C++ code base. So first we need to get the game object from the parent, or the parent which is the game object of this calling context. Then we get the transform component out of that, and then we do a few asserts to make sure that we have a transform, and that the transform is a physics transform. Then we can cast it to a physics transform component, and we can make sure that it's actually a character controller and not a rigid body. Finally, we cast it to a character transform component, and then call get character controller on that. Cast it to an int pointer T, and Bob is your uncle. So kind of nasty stuff, but there you go. Cool, I think that should be it. We should now be able to use that to our advantage. So the enemy component already has quite a lot of different things going on. I'm thinking maybe when we will create a new maybe we'll create a new component which handles the movement, and then this guy can actually just forward the path or the direction to that one, which gets the character controller and everything. So I think that's what we're gonna do. Well, let's call it AI character movement component, so that we can, at least in theory, use it for non-enemies as well, if we have anything like that. Right. Let's get this one. It's pretty short. So it was AI character movement component. We don't need it to be an avatar tracking component. It can be just a game object component, like so. So that's the context handled. We'll probably need the tick, and we'll probably want to do things only on the server. So let's hold on to that. What else? Then we'll want const character controller equals basis physics character controller. And Zig is kind of interesting in the way that you can do certain things like something. I think this would probably work. And build, yeah, like you don't get any error until you actually use this somewhere, because this is kind of orphaned code currently. Then when we actually register that code, now we'll probably get, now we get like all right, that's not what I meant. Do that instead. Yeah, unreachable code. It's like, what? No, the error message is a bit weird, but now it actually did pick up on our mistake there. Oh, it was unreachable because we are returning before that. Yeah, but now if you do that, then it'll give us a more sensible error. No, actually the error was perfectly sensible, but the use of undeclared identifier or something. It doesn't actually care about this thing before you, or until you actually use the code, which is a little annoying coming from a C++ word, where you can be sure that everything is correctly handled for you. So I tend to want to register these guys immediately when I create them, because it makes it so that they are actually used. All right. Now then we can go here to our blueprint and just change that to an AI character movement component. And now we'll have use for this onParent created that I was talking about earlier. So this guy, onParent created, gets called when everything has been created, and here the character transform component creates the character controller for us. And it's a little unclear at which point it creates it, but the order is the same as the actual component creation order is the same as this list here. So this gets created first, then the mesh, then the movement, and then the enemy. So by the time we reach onParent created in the movement component, the character controller will be available. At least that's what I'm hoping. So let's do this. Character controller, like so. And we'll actually probably need to do one more thing here. I might have some other struct here that has an init null. Doesn't seem like I do, but this one has one at least. I know. Since you need to initialize things, which is good. You can't just leave that uninitialized. You need to have CPP pointer be something. So I typically have like an init null in these classes. For some reason the physics stuff doesn't have it, but that's probably because they have these create functions that are used to create them. But yeah, now we can just use this and call character controller dot init null, and it won't complain when we actually create it here. I think this is not gonna fly. No. Oh, test component again. That's the self thing again. Yes, so it's pointing to return self, which is this guy, and it's like, you haven't initialized it. It's like, well, I don't want to initialize it there yet. I only want to do it in parent created, because the character controller won't necessarily be available there, but it should be here. So self.characterController is, and now we can use our new context transform, and then get character controller. And that should give us a valid controller. Okay, what do we have? C node. Line 11. What? 23. Scene. Yeah, more copy paste bollocks. Okay. Okay, very cool. I did a lot of work just to get this one guy here. Maybe as a test we should see if this guy works immediately. So let's get the pre-tick function implemented. I'll put it here. Again, pre-tick is where we should give the orders to the character controller, because it is run right before the physics simulation. So set movement vector, and we can just have them move in like along one of the axes. So let's do like vec2 unit x, I think is what I named it. Oh, I didn't name it anything in vec2. Well, we can do that. Why not? I only have 0, so let's just put this here. So we have 1 and unit x and unit y. There we go. Alright. Same thing as every year, James. And we don't have vec2. You don't realize how many errors you make when you don't have Visual Studio, like immediately highlighting your mistakes. You make a lot of small mistakes without it. Okay, cool. So now immediately when they are spawned, they should start moving along positive world axis x. Yeah. And the tick currently doesn't do anything, but we'll probably need that later on, so let's leave it for now. Let's see if this works. Yeah, there we go. They move very fast, actually. So makes it kind of hard to see what they're doing. We could just slow it down quite a bit and try that again. So let's do like 5 or something, 005. What? Yeah. Do I have any? No, probably not. Actually, var v. No, we don't need to do that. We can. Jesus, I can just do this instead. We can do init 005 0. That should be better. Yeah, so one thing that I'm missing from C++, which is typically considered quite evil, is operator overloading, but it's really handy with things like vector classes. Can't be helped. Zig doesn't have them. Okay, right. So it's pretty cool. You can see them doing their paths, and they keep updating them once every second. Seems to work fine. So at least we know that the character controller stuff that we did, while quite horrible code, is working. So that's good. That is very nice indeed. So maybe we can now finally start thinking about the actual movement logic. So this character movement component still doesn't know anything about the path. It's the enemy component that knows about the path. And maybe... I wonder if we should actually just like move this stuff to the movement, like the whole who owns the path and etc. Because I have a feeling like the enemy component will contain a lot of like other things that aren't directly movement related. So I think we'll move this to the movement component. Like this, and that as well. Now we can just get rid of it from there. I'll get those as well, constants, like so, and then we'll actually want to have this function here as well, find path to player. And I think the only thing that we'll do here in the enemy is just tell the movement component where the enemy is. So this is stuff that we can definitely run on in tick. So let's do that, and then we can actually get rid of that. That's supposed to be there as well. I'm almost certain that we'll need tick later, so I'm not gonna remove it. Just put those there, and maybe we'll move this update there as well, because we can actually leave it there, but we'll probably want to draw the path that we're going to take. So let's do that. And this is all stuff that is okay to leave here. Actually, we might want to have the last known player position there as well as a member as well. Let's just put that there. Maybe it can be shared somehow between those two, but it doesn't matter. It doesn't matter. It's fine. It's fine. Okay, so we could have a public function set last known player position. And the reason I'm doing it like this is that I think the enemy component will definitely need to know for a variety of reasons the last known player position. So it's pretty good that it is the one that receives this message. This movement component is not supposed to receive any messages. It's simply supposed to move to a position. Maybe actually we'll just put it like target position, because like we determined earlier, this is not necessarily only used for enemies. Invalid, that would be invalid target position, and we'll put it there, and this can just be target position, like so, and self dot target position equals pos. Right. Like that, yes. And we find a path. One path to target is what we are going to call that. And target just happens to be the player. Last known player position, well, that's the target position. Alright. Invalid player position is still there, so let's do it like that. Okay. So now we have more kind of well-defined responsibilities. This is supposed to keep track of where the player is and do evil things to the player, and this is simply supposed to follow what is given to it through this set target position function. Blah blah blah. Okay. Yeah. Right. So this is where the thing, the next stuff comes in. So now we need to actually set the movement vector. And how do we do that? Right, so if we have, let's just run the game, even though it doesn't compile, we can still use the previous one. So let's actually move somewhere where we have a few of these points. So if you consider like these two guys here, it has a path, it has 3 points. It needs to start targeting the second point. So it has essentially like target point on the target index on the path, which if this would now just create this path, it would set this, in other words, index 1 as the target point, and then it would start tracking towards that. And that's actually probably a pretty good start to just get that done. And then we need to figure out probably in tick if if it has reached that point, and then it will just increment it, yeah, to the next one. Okay, so we'll do something like current target, current path point index, right? That's going to be an unsigned int, and it's 0. And when we have found the path to the target, if self movement path result is basis nav mesh runtime nav mesh result okay, then self dot current path point index is 1. Right, this is safe to do because there's not going to be a path without at least 2 points. So the point with index 0, with index 0 and 1 are always going to be valid. Yes. So that's good. So start moving towards the second point on the path. And then here we'll just add a to do if we are close enough to the current point, move to the next. Right, that's essentially the logic. And in pretic, we simply do if I think this is probably the best way to check if we have a valid point at the moment. Maybe not, but let's go with it anyway. I'll keep formatting. I keep hitting save and it keeps formatting. So we will want a direction vector, and current position, and that's self context transform get position. And then we have const current path point, which is self movement path self current path point index. There's a v there, which is not supposed to be there, like that. And then we take we do what do we do? We do const direction vector is current path point, and we subtract the current position from it, right? And then we do, actually that needs to be then a variable, but not a capital one, because now we can do normalize. I think all of that is available. Okay. Debug draw. Right. Time between path queries. It's also supposed to be here, not in the enemy component. Oh, there's another self somewhere. Where's the self? Self. Yeah, at least the compilation process is quite quick with Zig. So that's nice. Okay. So now we have a direction vector. Let's add like a movement speed. What did we actually use for the character the C++ code. So use 5 times the tick delta time. Okay. And this is probably gonna be put somewhere more nice so that it can be adjusted. So self time. Actually, no. Let's just do this first. Var. What do we have in like multiplication? We have dot add sub length normalize transform blur blah blah blah. No, we don't. We don't have that. We probably should, but I'll want to spend a bit of time figuring out what to call those exactly, since it's like math library functions. So let's just do movement vector equals direction vector. I think we can do that. And then movement vector dot x. Can I do this? I think I can. Tick delta time times movement speed. And then the same thing for y. And then I'll probably need to use that, or this is gonna get cranky with me. So something like that. Right. Oh, and okay, yeah, of course. Let's make that a vector 2. I can't decide how I want to do this. Movement vector is vec2 init, and then something like that. Nope. Something like that. Nope. That looks like it went through the parser at least. Let's put the comma there to get the nicer formatted version of it. Okay. And yeah, that's not actually supposed to be y, but z, because it's a 3D vector. Yeah. Yeah, that should be fine. Let's try to build that. No, of course, it's not that. It's direction vector. Yeah, I usually do my math in 3D, and then if the thing I'm using expects a 2D vector, you can just remove data from that. It's typically easier. Okay, well that is not exactly what we want. They all move towards the origin, and of course I know why that is. It's quite simple. We haven't called that target position. So how do we do that? Oh, crap. And I actually did this previously when I experimented in Slide with like getting a sibling pointer, but I can't remember what that looked like. So let's have a look at the Slide Zig code. And it's this one. Right, so we have a Zig crane avatar component which has as a member a crane control system component. So we can use this and do the same thing for the enemy component. So let's just get the name of this guy do const basis component contexts. No, that's not what we want. We want to import that and then do right. So that thing, and then we'll want something like this. So we do like movement component, and it's an optional pointer to a character movement component, which is initialized to null. All right, and then later on we do this on parent created, and it's important that we do it there. Actually, we can just copy the whole thing because we don't seem to have it anymore here. And then just right. So yeah, it's important that we do it here because if we did it in create, then it's not necessarily true that the sibling has been created yet. So we get from the parent, we get a component of this type, and with this name, so it's movement is what we call it. My phone keeps on ringing. There we go. Right, and then the way we use that is, since it's an optional, we actually need to like check if we have it or not. And then this, in this case, in the capture, we have the component that we can actually call. So let's just test it out right here. Well, this might actually be where we'll want it in the end as well. So it's called MC movement component. It's actually with pipe symbols. And then mc.set target position, and that would be last known player position, like that. And we'll see if that builds. And it does. And does it work? Would you look at that? Now, of course, the enemies, they kind of only move the first move to the or move from the first to the second point. So if, for example, if we have a very long distance between those guys and the player, then I think let's see if I can put some distance between them. If I stand here, well, they will eventually go there because they will make a new path, which will then be kind of closer to the player. But yeah, I think it will look nicer when it will sort of using just one path. If there are no new paths available, it will navigate the path to the end rather than just always targeting the second point. But yeah, this already looks a lot nicer and a lot more intimidating when those guys are coming at you. They don't look very enemy-like yet, though. They're just kind of like your posse. They do know how to navigate the world, though, and that's very nice. That's nice. Okay. well, I think this counts as basic movement, which is what was the target for this video. I think we'll end it here, and I might improve the movement a little bit off camera or on camera. Let's see how I feel. Anyway, thanks for watching. Until next time, bye.